All right, so here's the integral of a linear over the root of a quadratic here. And so what I'm going to do is I'm going to take the quadratic and I'm going to make it equal to u. And then I'm going to differentiate it. And then this derivative, what I'm going to try and do is I'm going to try and build it in the numerator here, okay? And so it's negative 2x plus 4. All right, so I'm going to try and build that. I've got a 2x, so I'm going to make it negative 2x plus 4, right? And how do I do that? I've got a negative 3 here, so if I add, if I subtract 1 from this 4, it gives me a positive 3, okay? So, because 4 minus 1 is 3. And then that negative sign actually is been factored out. So if you kind of imagine simplifying a negative 2x plus 4 minus 1, you've got that. So therefore, there's the derivative of this guy, which is kind of nice. This minus 1, I'm going to move over here, separate out my two integrals here, and I'll keep my denominator, right? And the negative also has to go with it, this negative and that negative there, okay? And so now if I use my u substitution over here, du is this thing, a negative 2x plus 4 dx. That's a negative 2x plus 4 dx is just du, and the square root of u, which is the, this thing, okay? Look at that. And now that one's going to be really simple. Over here, my negative sign factors back in, giving me a positive. This one I'm going to use completing the square on. And so what we've got is a negative, and then we've got an x squared minus 4x plus 3. So what I'm going to do here, I factored out a negative, okay? And then I'm going to add 4 and subtract 4, giving me a perfect square trinomial here, which ends up being x minus 2 squared, okay? Check out completing the square for this. And then that 3 and the 4 combine to be a negative 1. Now this negative sign that I factored out before, I can factor it back in, or distribute it back in, and this negative 1 became the positive 1, and the negative x squared plus x squared minus 2 squared is right here. And now if you look closely at this is just a sine inverse, right? Integral from your basic integration tables. And this one here is, what did I do here? Over here, I integrated du over root u, which is just 2 root u, okay? Again, that's another basic one from way back. And then over here, where are we looking at? I just resubstituted my u back in. So u, remember, was way up here is what I made at the beginning, okay? And so there it is. It's a negative 2 root, that thing, the quadratic, the original quadratic, plus the sine inverse of that. All right, so there's my final integral there. I did this in a different way as well, so I'll post that link of that one in the description.